Now let's have another example for our application of the effects of friction on the motion of the object. So in this case, we have this example here wherein we have a box again lying on the rough surface with a coefficient of static friction which is 0.3 and a coefficient of kinetic friction of 0.15. And let's just assume that a force of 50 Newton was applied on the box. Now, for letter A, we are to calculate the frictional force on the box. And for letter B, we will find the net force on the x-axis, and letter C, we will calculate the box acceleration. So first and foremost, before we deal with the calculation, first we need to find the coefficient of the the frictional force due to the static friction first. So to solve this, we have to go back to our formula of the frictional force formula due to the static friction, wherein mu sub s is multiplied to the normal force of the box. So again, we have forces acting on the y axis where we have our normal force here, and of course we have our gravitational force here which is equal to mg, and we know that Fn here in this case is equal to Fg, which is equal to mg. Okay, so therefore to calculate our frictional force here, we have to multiply 0.3 by your normal force, which is equal to mg in this case. So we have here our 5.0 kilogram multiplied by your 9.8 meter per second squared constant of gravitational acceleration. So if you plug this in your calculator, we will get the result of around 5 times 9.8 times 0.3. So this is around 14.7 newtons. 14.7 newtons. Okay? So that is now the amount of our frictional force due to our static friction. Let me just label this one, due to the static friction. So therefore, in order for you to completely move this box, you need to overcome this static friction of around 14.7 newtons. But as you can see in this example here, the applied force is clearly 50 newtons, way bigger than our frictional force due to the static friction. So therefore, our Fr here in this case is actually less than our F sub P. So therefore, the box will move. So the box will move on the direction to the right, because as what I've said, it's where the force is being directed. Okay, so it will move to the right now. And of course, in order for you to calculate letter A right now, since the box is now moving, then we have to calculate the frictional force. Take note, calculate the frictional force due to the kinetic friction, not the static friction anymore. Now, why did we calculate this first? It's because we need to know if the force applied, which is 50 newtons, has an effect on the box. And since we verified that our frictional force due to the static friction, which is equal to 14.7 newtons, is less than the applied force, which is 50 newtons, then it will move, or the box will move. So therefore, since the box will move, we need to use the coefficient of kinetic friction to solve for the frictional force. So our frictional force in this case would be equal to the mu, or the coefficient of our kinetic friction, multiplied by the normal force of the object. So in this case, this is 0.15 multiplied by 5.0 kilograms times 9.8 meters per second squared. So our frictional force due to the kinetic friction here would be equal to 0.15 times 5 times 9.8. That is 7.35 newtons. 7.35 newtons. If we are going to draw that in our diagram here, our frictional force here due to the kinetic friction right now is going on the opposite direction, which is here 7.35 newtons. Okay? So in this case, we can now solve for letter B, because the net force, or shall we say, the sum of all the forces in the x direction is just equal to the force applied plus the frictional force that this box is experiencing. So the sum of all the forces in the x direction, which in this case our force applied is 50 newtons, then since our frictional force always opposes the applied force, it is denoted with a negative sign. So this is minus 7.35 Newton. Okay? So therefore, we have a net force of around 50 minus 7.35. So if we calculate that, 50 minus 7.35, that is 42.65 newtons. 42.65 newtons. That is now our net force for this particular case. And in order for us to calculate letter C, the acceleration of the box, all we need to do is just use the formula for the second law of motion, wherein the net force is equal to the mass of the object times its acceleration. Okay? And to get the acceleration here, all you need to do is just divide the whole equation by its mass so that we can cancel the mass on this side, and we get a whole new equation, or the acceleration, wherein it is equivalent to the sum of all the forces in the x direction divided by the mass of the object. So plugging this in, we know that our sum of all the forces in the x direction is 42.65 newtons divided by the mass of the object that we had a while ago, which is 5.0 kilograms. 5.0 kilograms. And just to show you how the units are being cancelled, we know that 1 Newton is equivalent to kilogram meter per second squared divided by your kilogram unit here. The kilogram unit is cancelled here, making this meter per second squared our unit for acceleration. So therefore, our acceleration for this case divided by 5, this is around 8.53 meters per second squared. And that would be our final answer for this problem. So I hope that this particular example has somewhat shed light from you on how the frictional forces from the coefficients of static and kinetic friction affects the motion of the object as we apply Newton's laws of motion. So that would be all for our example for this video. So thank you so much for listening, and I hope to see you in our next discussion. Bye!